We can use the midpoint formula that we learned to solve some application type questions. So both of these applications specifically relate to a triangle. We know that a triangle is obviously a three-sided shape. And because we are working on a Cartesian plane, sometimes we can describe a set of 3 points that when connected would create a triangle. And we can use what we know from linear relations as well as some of the things that we are learning in this unit, analytic geometry, to determine some key characteristics of a triangle. So it's important first to know what these characteristics are. So the median of a triangle is a line that's drawn from one of the vertices to the midpoint of the opposite side. Okay, so a line drawn from one vertex of a triangle to the midpoint of the opposite side. Okay, so I'm going to just draw a little diagram to show you what that might look like. So let's say we've got a triangle that looks like this, and we're going to call it ABC. We could find the median for any of the vertices, but let's say I wanted to find the median through B. That's how we say it. So these would be a point on each of the vertices because they would be plotted on a grid. Okay, so we would have the midpoint of line AC, which I'm just going to be approximating because obviously I don't have a ruler for this, but the midpoint is maybe right there, maybe a bit more to the left. And so your median would be the line that goes through these 2 points. Okay, and we would call that the median through B. We could also find the median through A or through C. Okay, so any triangle will always have 3 medians because you can find it through either, any of your 3 vertices. So if you are given the corner points, these are the steps to find the equation in slope-intercept form, y equals mx plus b, of the median. The first step is you want to find the midpoint of the line segment that is opposite of the vertex you're working with. So we will say find the midpoint of the opposite side, or I'll say, sorry, the side opposite to the vertex that you want. Okay, so in the case of the example that I showed above, you would be finding the midpoint of AC of that line segment. Okay, so I'm showing that in pink just because that relates to my specific example. Then once you have that midpoint, what you're going to do is you are going to find the slope between the midpoint and the vertex that you're working with. So the slope of the line through the midpoint and specified vertex. Okay, so again, in this specific example, it would be the slope between your midpoint and B. Again, I guess I'll just show here on the diagram. That's what I mean by M. Oops, that's my midpoint. Then, once you have the slope, you can create an equation in slope-intercept form. Okay, so y equals mx plus b. And you do that the same way that we were calculating equations yesterday. So by filling in your slope, so your m value so from step 2, and x and y from either the midpoint or the vertice. Okay, it doesn't matter which one. Because they are both on the line, right? If you look at the diagram of the triangle that I drew, that pink line there, points M and B, both lie on that line. So as long as you pick one, you would use that for your X value and your Y value. You would sub that in to get your B value, right, to isolate and rearrange, and then you would state your final equation. Okay, so obviously within that create an equation, there's a few steps that we outlined in more detail in one of yesterday's lessons, but I don't need to write all those steps out because you should know how to do that. So you'd fill in y, m, and x, calculate b, and then state your final equation. Now, similar to this, we can also use the midpoint and what we know about triangles and about slopes of lines to calculate the altitude of a triangle. So, sorry, I misspoke when I said use the midpoint because we don't actually use the midpoint for the altitude. But first I'm going to give you the definition. So the altitude of a triangle is a line that is drawn from a vertice. Okay, again, it doesn't matter which vertice you're using. So any vertice in a triangle, and it is perpendicular to the opposite side. Okay, so it is drawn from any vertice, sorry, that should be any vertex, single form, not plural, any vertex in a triangle to the opposite side. And the key thing here is that this line is perpendicular to that side length. Okay, so it makes a 90-degree angle with whatever side that it is meeting with. So again, if I draw an example of a triangle, let's say it's like this, and I call this A, B, C. Again, you can do this through any of the vertices. I'm just going to show it through B because that one's just kind of the most clear to see. It would go from the point B. Right, again, these are all points because they are on a Cartesian plane. So it would go from that point and be perpendicular to the other line. So if I were to draw this perpendicular, it would be sort of like this. It's kind of tricky to do when I don't have something to measure it nicely, but I think that is pretty close. Okay, so it's not through the midpoint, right? If we were to kind of show here, this makes a 90-degree angle. You can kind of see, obviously my diagram is not super exact, but you can see that the distance between A and where this crosses is shorter than the, sorry, it's shorter than the distance from this point to C over here. Okay, so sometimes, rarely, it goes through the midpoint of AC. That would just be in the case of certain types of triangles. However, it's always going to be perpendicular, okay, so not through the midpoint, but it makes a 90-degree angle there. And if you kind of turn the diagram to look and see if this was your base, really what this is giving you, this altitude, is the height of the triangle. Okay, so again, if I gave you the corner points of the triangle, the coordinates of them, we would follow these steps to find the altitude. Okay, so I'm going to reference this example again as well, and this is the altitude through B. You can find it through A or C as well. in this case, it was just easier to show you like this because it's the one that looks closest to a height, whereas we might want to turn the triangle if we were finding it through one of the other points. So the first thing that we need to do if we are given the points is we need to find the slope or calculate the slope of the opposite line segment. So find the slope of the line segment opposite to the given vertex. Vertex. Okay, so in my specific example here, we would want to find the slope of AC, okay, of that line segment. Then we would, from that slope, determine the perpendicular slope. Okay, the one that's perpendicular to line AC. And I always write that like this, so I show it as M, little m means slope, and then this symbol means perpendicular. Okay, it's showing that it's making a right angle. So determine the perpendicular slope, okay, or I guess I should have said the slope that's perpendicular to the slope from step 1. Okay, and you do that again, we talked about this yesterday, by finding the negative reciprocal. So you're going to flip the fraction and flip the sign. So if it's negative, make it positive. If it's positive, make it negative. Then you are going to create an equation. Again, it's an equation of a line, so it's going to be a y equals mx plus b equation. And in this case, you are filling in m as your perpendicular slope. Okay, so I'm going to say m is equal to perpendicular slope and x and y from the specified vertex. Okay, so in this case, you don't have an option for where you are getting the x and y coordinate from like you did in the median, right? In that one, we could pick either the midpoint or the vertex. But in this case, you would use your perpendicular slope and you would use your point B and get x, y from that. Okay, and then you would substitute those into your y equals mx plus b equation, calculate, simplify, isolate for b, and then state your final equation in slope-intercept form. Okay, so that is how you find the equation for both the median of a triangle and the altitude of a triangle. Let's take a look at an example using some actual numbers so you can see what this looks like. So I am given the end points, or sorry, the corner points of a triangle. Okay, so I have points A, B, C, and I want to determine the equation of both the median and the altitude. Okay, and I'm given the vertices that I am referencing for each of these. Okay, so first I'm going to start with the median. Okay, so this is the median through B. If you were having trouble visualizing this, you can plot this on a Cartesian plane just to kind of see what the triangle looks like. I might do that after just to show you what everything looks like when you plot it out. But if the median is through B, that means that I am going to first find the midpoint of the opposite line. Okay, so if my triangle is ABC, then I'm going to find the slope, or sorry, the midpoint of the line AC. Okay, that would be what's opposite. So my first step is going to find the midpoint of AC, because again, that's the line segment that's opposite of the vertex that I am working with. So I'm going to use my midpoint formula. If you want, you can write these values down here. So I'd have, this would be x1, y1, this would be x2, y2, and then I'm using my midpoint formula. So I'm going to do 4 plus -8 2, and 10 plus 4 divided by 2. And I'm just calculating here. So 4 plus -8 is just the same as 4 subtract 8. So that's -4 over 2. And then 10 plus 4 is 14. And we're dividing by 2. Okay, so the midpoint here is going to be -2, 7. Okay, so that is the point that the median is going to go through. Okay, it's through B, meaning that the line is going to be connecting B and M. Okay, so now my second step here is to find slope of the line through M and B. Okay, again, if you wanted to write the coordinates here, I might just show them. So B is 8, 2, and M is -2, 7. Okay, so we're using our slope formula. So this is the lowercase m formula. So your slope is equal to y2 minus y1. So 7 minus 2 over x2 minus x1. So -2 subtract 8. And then we are evaluating. Okay, so 7 minus 2 is 5. -2 subtract 8 is -10. And then we are checking, can we either divide this nicely or simplify it? So if you were to do 5 divided by -10 on your calculator, it would tell you -0.5, which you then should easily be able to turn into a fraction, or you could just leave it as -0.5 because it's a nice number. Or here, the way that I did this, I'm going to divide the top by 5, divide the bottom by 5, because that's the biggest common factor of both of them. And then I have my slope is equal to -1 over 2. Okay, again, remembering that we can pull that negative sign out front. We don't need to keep it with the or with the 10 on the bottom. We can just say that the slope in general is -1/2. So the last step here is going to be calculating the actual equation of the line, right? So we're going to make a y equals mx plus b equation. And we are going to let m be -1/2. And then I can pick either of those coordinates for my x and y. So I'll just use that 0.82. So I'll say x is 8, y is 2. And it doesn't matter which one you pick. I'm just doing this one to, no, they both would give you a nice answer because you've got the fraction there. I typically try to pick the one that would give me the one that's not as messy if there's a fraction slope, but they both will calculate it out. Okay, so we will have 2 is equal to -1/2 multiplied by 8 plus b, and then we are just simplifying and isolating, so this side is still 2. -1/2 times 8, so either make sure you are confident with multiplying fractions, or you can just do this on your calculator. This is the same as just saying like -8 divided by 2, so -4 plus b, and then we are isolating for b. So we'll add 4 to this side, add 4 to this side, and we have 6 is equal to b. Okay, so we can then state the equation of the median through b. Okay, so the median through b is given by y equals -1/2 x. Okay, again, you don't need to fill in a value for y and x, you just leave them as variables, plus 6. All right, so that is the equation of the median through B of that triangle. The next thing that this asked us to calculate is the altitude through A. Okay, so I'm just going to copy this down here so we can see the question again when I'm starting out. Okay, so I just wanted this so I could see my points again. So I'm calculating the altitude through A. which means if you think like the height, if I start from point A and it's going to be perpendicular to the base, in this case, the base is line BC. Okay, so the first thing I want to do is I'm going to calculate the slope of the line that's opposite to A, which I said is BC. So slope of that line segment BC. In this case, this is not what my coordinates are anymore. I'm just going to cross them off and just write my points here. So point B is 8, 2, and point C is negative 8, 4. Okay, so I'm calculating my slope, which again is little m. So I'm going to do 4 subtract 2, that's my y2 minus y1, over negative 8 subtract 8. Okay, so x2 minus x1. Then I am simplifying, so 4 subtract 2 is 2. Negative 8 subtract 8 is negative 16. And then I'm going to fully simplify. Okay, if you type 2 divided by negative 16 into your calculator, you do get a decimal place that's actually not bad. You get negative 0.125, but I just like to keep it as a fraction because, especially in this case, we are going to find the perpendicular slope, which means we need to flip the fraction. Okay, it's pretty difficult to flip a fraction when you have it as a decimal, so we're going to leave it as a fraction here, but just simplify a bit. So both of these are even numbers, so I can divide them both by 2. And then again, I'm going to pull out that negative sign to the front of the fraction just so I don't forget about it. So this is negative 1 over 8. Okay, so that is my slope of the line segment BC. Then what I need to do is I want to find the perpendicular slope. Okay, and again, I do that by finding the negative reciprocal. So I'm going to flip my fraction and change the sign. So if m is negative 1 over 8, then my perpendicular slope, which again I show like this, is equal to, I'm going to flip the fraction like I said, 8 over 1. It was negative, so it's going to be positive now, and we can just say this like this. Our perpendicular slope is just equal to 8. Okay, some people like to keep it 8 over 1, just 8 is fine because that's really what that's showing there. Okay, so that is what I'm going to use as the slope of my altitude. So now all that's left to do is to make my equation, y equals mx plus b, and I'm filling in my variables, so I'm going to let m be equal to 8. Okay, I'm using the perpendicular slope. Be careful here that you don't go back and use the original slope, because if you do, then the line you're calculating will not be perpendicular to the base, and it won't actually be the altitude that you are looking for. Then x is going to be the x coordinate of point A, because that's the point that I'm going through, so 4. And y is the y coordinate of point A, so that is 10. I'm just going to show here that's where I got that from. So point A is 4, 10. Okay, and it's important that you're using the coordinates of the point that is specified in the question. So it specifies that we want the altitude through A. Okay, you don't want to use B or C because that, again, will give you the incorrect equation. So this will be 10 is equal to 8 times 4 plus B. And then we are evaluating, simplifying, isolating. So this will be 10 is equal to 32 plus B. And then we want to isolate B, so we're going to subtract 32 on both sides. And that gives us B is equal to negative 22. Okay, so then we could say, therefore, the altitude through A is given by this equation, y equals 8x minus 22. Okay, and that is the equation of the altitude. I am going to graph this triangle and both the median and the altitude just to show you what it would look like on an actual grid. Okay, so I've got my Cartesian plane set up here, I'm going up by 2's on my y-axis and then by 1's on my horizontal axis, the x-axis, just for the sake of space, because I do have that equation of the altitude that has a y-intercept of -22, so I needed to have room to fit everything on here. So the first thing I'm going to do is I'm going to plot my points A, B, C. Okay, so I have written the equation or the coordinates at the side there just so I can remember what they are. So A is at 410, so that is going to be right here. I'm going to label that as A. B is at 8.2, which is over here. And C is at -8.4, which is over here. Okay, so those are the vertices of my triangle, and I'm going to just draw some lines to connect them so that you can see the actual shape of it. Okay, so the entire triangle is in that kind of like upper positive part of the y-axis, but we know that the equation of one of the lines needs to have that negative y-intercept. Okay, so these are my vertices. I'm just going to label them with the coordinates here so that you can see where each one is here. Then what I'm going to do is I am going to graph the equation of both the median through B and the altitude through A. Okay, so the first one that I'm going to do is this one, the median through B. So my equation of the line is y equals 1/2 x plus 6. So if you recall from the lesson on how to graph an equation of a line, we are going to start with the y-intercept. So that is 6. So that's going to be right here. Okay, and then I'm using my slope to find where my next point is going to go. The one thing to keep in mind here is that because I'm going up by 2's on the y-axis, I just need to make sure that I'm actually, when I'm going down 1, right, my rise over run, it's down 1 over 2. I need to make sure that I'm going down actually only 1, which is kind of, it's going to look like a half step here. So going down 1 over 2, which would be about here. I'm going to just put that as a small point because I'm actually going to just do it again. Go down 1 over 2, and then this is where my point will actually be, just because that's a bit more, I don't know, clear where it's going. And then I am going to draw my line, and I know it has to go through B, so I'm going to connect my y-intercept, that other blue point that I drew, and my vertex B. So I'm going to do that here. I'm going to just extend it so you can see like on if it was to keep going in either direction. Okay, and then extend it this way as well. And we know that that median has to go through the midpoint of AC. So actually, I'm just going to scroll back up here to see what that midpoint was. So the midpoint of AC was -2.7, which if I look here, I guess I could have done that before. So -2.7 would be right about here. It's not perfectly exact just because it's hand drawn, but that is point M, which is -2.7. And we see that that median there goes nicely through B and M. Okay, so that's what the median through B would look like for this triangle. Then we are also going to graph the altitude through A. Okay, so this one is going to cross through vertex A and be perpendicular to line BC. Okay, so again, I'm going to start with my first point being the y-intercept. Okay, which is here all the way down at -22. Then my slope is 8, so I'm going up 8 over 1. Again, keeping in mind that each square is actually 2, so I'm going to go up 2, 4, 6, 8 here over 1, which is going to be here. I'm going to do just one more point, so going up 2, 4, 6, 8 over 1 here. You could keep going until you get all the way to A, but we don't need to do that. I'm just going to connect those green points and vertex A because again, I know that this line is going through A. So I'm connecting here. And I'm going to extend it on both sides here, just a little bit so you can see. And obviously this isn't perfectly exact, especially because my scale is different. So if I'm looking at this, this does not appear to be a 90-degree angle. If I were to get a protractor and measure it, it definitely is smaller than 90 degrees. That's just because of the scale of it and because it's a hand-drawn diagram. However, that is the altitude that would give you the height of that triangle.